10 gallons of water leak from a hose in 20 hours. At this rate, how much water will leak in 10 days? So the proportion could be, right, 10 gallons for 20 hours. That's the rate of leaking, right? 10 gallons for 20 hours. And then here we're asking how much water, how many gallons, in other words. So in other words, we don't know the gallons, we want to know the gallons. Well, we wouldn't actually do this, right? We wouldn't do this because we have 10 days. Gallons are the same on top, but the hours are not the same here. So actually what we need to do first is change 10 days into hours. There are 24 hours in one day. There's going to be days, hours in one day. Days cancel. So we get 10 times 24 or 240 hours. And here I can already see the solution, right? We have 10 times 2 is 20. So we have to do x times 2 is 240. In other words, 120. 120 times 2 is 240. You can also see this by doing it this way. 20 times what is 240? 20 times, let's see, that would be 20 times 12. 10 times 12. 10 times 12 is once again 120. We can, of course, solve this by using cross multiplication. That's going to give us 10 times 240 equals 20x. That's going to be 2400. Divide by 20 to get x by itself. The ones cancel, and 240 divided by 2 is 120. So 120 gallons is how much water would leak from the hose in 10 days. All right, for the next one, we have 15 bags of seed are enough to sow 5 acres of farmland. How much seed is required for 48 acres? So how much seed, this is going to be our variable. You could use the variable x. Let me use the variable b here for bags of seed. 15 bags of seed for 5 acres equals b bags of seed for 48 acres. So you can see I have bags of seed on top and I have acres on bottom. So I can use this proportional reasoning to solve for this. What I can see is that 5 times 3 is 15. That means 48 times 3 will be my solution. So we know that the bags is going to equal 48 times 3 is 144. I just want to show this as cross multiplication as well. So cross multiplying. 15 times 48 equals 5 times b. Divide by 5. The reason why I'm doing that first is because I can see here 5 and 15 reduce. But you can also just do 15 times 48 first. That's going to be 720 divided by 5. And 720 divided by 5 is 144. So 144 bags of seed is required to sow 48 acres. All right, 28 tapered pins can be machined from 12 feet of steel rod. How many can be made from 9 feet of steel rod? So we have 28 tapered pins for 12 feet equals how many can be made from 9 feet? So we have 9 feet here, which means our variable is going to go here, right? We have tapered pins, so you can use just the variable x there for pins if you want, or you could use the variable p if you didn't use the units. But you can see we have the pins on top and feet on bottom. So I can't see any easy relations. I can see that this one here really is 4/3. But that's not readily apparent. So what I would do here in this case is cross multiply and divide. So 28 times 9 equals 12 times x. 28 times 9 is 252. And now I can divide by 12. So divided by 12, I get 21. So 21 tapered pens can be machined from 9 feet of steel rod. Okay, Mary earned $112.50 working 12 hours. If she works 15 hours, how much would she make at the same pay rate? What we could do here is find the unit rate of pay. So $112.50, that's going to be dollars for 12 hours. That's going to give us $112.50 divided by 12. It gives us $9.375 per hour. So if she makes $9.375 per hour, all we have to do is multiply that by 15 to give us 140.625, or in other words, approximately 140.63 dollars. That's what we expect. We can also use a proportion to solve this. 112.50 over 12 equals, this is dollars per hour, so we don't know how many dollars she's gonna make. I'll use the letter D for this variable, and then 15 hours goes on bottom. Now I can cross multiply and divide. 112.50 times 15 equals 12D. So I get 1,687.5 equals 12D. Just divide by 12. And I get 140.63 when rounded to the nearest cent. So either way, it works out. Okay, the scale on a map is 1 inch to 20 miles. So it's going to be 1 inch on the map is 20 miles in the actual distance. What is the actual distance of two towns that are 3 inches apart on the map? So we have 1 inch goes to 20 miles. Then we have 3 inches on the map. And we're asking how far apart is this? So what's the distance in miles? Well, I can cross multiply and divide here. I can also see that 1 times 3, right? So 20 times 3 is going to be 60. I can also see here that 1 times 20. So here I can do 3 times 20. 3 times 20 is 60 again. So D is going to be 60. But to show that in cross multiplication, 1 times D is just D. And 3 times 20, or 20 times 3, gives us D equal to 60 miles. So everything checks out. No matter which way I do it, I get the same answer. Okay, in 2012, President Obama at that time visited Phnom Penh in Cambodia for a summit. The traffic was slowed to a rate of 2 miles in 4 hours. Wow. How long would it take someone to drive 3.5 miles at this rate? Well, 2 miles every 4 hours going to equal 3.5 miles for X hours. Or you could do T hours, probably would make more sense because T stands for time, right? Time in hours. Cross multiply and divide, I get 2T equals 4 times 3.5. Let me do that on a calculator. 14 divide by 2, and I get T equal to 7 hours. It takes 7 hours to hit 3.5 miles. I could see here actually that 2 times 2 is 4. That means 3.5 times 2 is 7. Going this way though, 2 times what is 3.5 is a little bit less clear. Okay, Ryan can mow 3 lawns in 5 hours. If he got very busy one day and mowed 7 lawns, how many hours did it take him? So 3 lawns in 5 hours equals, we know he mows 7 lawns, so this is going to be our time in hours. 3 times what is 7, 3 times what is 5. That's not apparent to me, so I'm just going to cross multiply. 3t equals 5 times 7 is 35. I can divide by 3. That gives me t equal to 35 divided by 3 is 11.6 repeating hours. So approximately 11.7 hours. Okay, last problem. We have a photographer needs to dilute a chemical in the ratio of 1 part chemical to 7 parts water. So 1 part to 7 parts, this is actually the ratio 1 to 7. How many ounces of chemical should the photographer use if 3 quarts, so here, ounces and quarts, if 3 quarts of the final solution is desired? So 1 part to 7 parts, this is a way of referencing any kind of quantity. It doesn't matter what unit you use, you're always going to use 1 part to 7 parts. So since we're asking for how many ounces, what we can say here is 1 ounce to 7 ounces. If you wanted gallons, it'd be 1 gallon to 7 gallons. That's what's one usefulness of a ratio, is that the units can get changed when you use a ratio like this, 1 part to 7 parts. Okay, we want ounces, so we have 1 ounce chemical to 7 ounces of water. That means in total, right, this would give us 1 plus 7, 8 ounces of final solution. 1 plus 7 is 8, right? You use 1 ounce of chemical and you add that to 7 ounces of water. That's a total solution of 8 ounces. That's going to be important because we want 3 quarts of a final solution. Now we're working with ounces here, so let's not work with quarts. Let's work with ounces. So we want to do a unit conversion from quarts to ounces. I know there are 8 fluid ounces to 1 cup. There are 2 cups to 1 pint, and there are 2 pints to 1 quart. So there's going to be 4 cups to 1 quart. And if there's 4 cups to 1 quart, there's 4 times 8 is going to be 32 ounces to 1 quart. So if 3 quarts are desired, we're going to have 3 quarts times 32 ounces per 1 quart. And we get 96 ounces. That's how many ounces we want of the final desired solution. And as you can see, we get 8 ounces when we do a single mixture of this ratio. Of course, you can just go from quarts to pints, pints to cups, and then cups to ounces. You can do that in each step if that makes more sense to you. But I just wanted to do it all in one go. All right. So if we want 96 ounces of our final solution and we get 8 ounces, this is the same thing as asking, we have 96 ounces divided by 8 ounces. How many times are we going to use this ratio of 1 ounce to 7 ounces? So this is just one way of solving the problem. We do 96 divided by 8, that says 12. So we're going to use 12 of these and 12 of these. 12 times 1 is 12, 12 ounces. 7 times 12 is 84 ounces. 12 plus 84 gives us 96 ounces of solution. 12 ounces of chemical mixed with 84 ounces of water. 12 plus 84 is 96 ounces total that we get. And that's exactly what we want. 96 is the same thing as 3 quarts, and 3 quarts is our final desired solution. So all I really wanted to do there was figure out what's the scaling that we need to do. So this is for a single 8 ounces, but we don't want 8 ounces. We're asking how many times can 8 go into 96? You just need to make it 12 times as big. That's what I was trying to find by doing this division here. We can also solve this in a slightly different way. If we look at, again, 1 ounce to 8 ounces, so 1 ounce of chemical, I'll do it like this, 1 ounce chemical to 7 ounces of water. That means we're going to have 1 ounce chemical to 8 ounces of solution, total solution. Again, 1 plus 7 is 8. So this can be written as a proportion. 1 ounce chemical to 8 ounces solution equals, well, what we want is 96 ounces of solution. The question is, how many ounces of chemical do we need? Well, it's going to be X ounces of chemical. You can see I have chemical on top and solution on bottom. We cannot use this, right? This is 7 ounces of water. We want total solution because we're asking for 3 quarts of final solution. So just make sure that the units are correct that you're talking about. Well, we can cross multiply and divide if you want. You can also see that 1 times 8 gives us this. So what times 8 gives you 96? Of course, cross multiply and dividing will find that. So it's going to give us 1 times 96 is 96. 8 times x, divide by 8. And I get x equals 12. So x is ounces chemical. In other words, we have 12 ounces of chemical that is required for this situation.